Ever had this brilliant idea for an app or maybe a program, but you just got totally stuck on where to even start? Well, today we're going to pull back the curtain on the secret first step that all great programmers take. It's all about creating a visual plan that can turn a really complex idea into functional, elegant code.
Okay, let's start with a feeling I think we've all had. Picture this. You've just bought some of that flat pack furniture. You open the box, and 100 little tiny confusing parts spill out all over the floor. And of course, there's no instruction manual. You know that feeling of rising panic? Yeah, that's a recipe for absolute chaos and a whole lot of frustration.
Well, believe it or not, writing code without a clear plan feels exactly like that. I mean, you have all these powerful commands and functions right at your fingertips, but without some kind of structure, it's just a big jumble. The good news, though, there's a really simple and frankly brilliant tool that brings order to all that chaos.
And that tool is what we're calling the blueprint for code. We're going to build this blueprint using something called a flowchart, which lets us visually map out our entire program before we even think about writing a single line of code. So let's see how this actually works.
So what is a flowchart really? To put it simply, it's the instruction manual for your program. It's a diagram that uses just a few basic shapes to show the entire journey of your code. You know, how information moves, what decisions it makes, and what actions it takes from the second it starts to the second it ends.
But why is this so powerful? Well, it's because our brains are just wired for visuals. A flowchart takes a messy, complex idea and makes it look simple. It becomes this universal language that a whole team can understand, cutting right through the technical jargon. This efficiency saves tons of time and headaches. And because it's visual, we're way more likely to actually understand and remember the logic.
Okay, so we've got our blueprint, but what are we actually building with? See, every programmer has a toolbox of essential elements. So let's pop it open and take a look at the first two.
Our very first tool is the variable. And honestly, the best way to think of a variable is just as a labeled box. We give the box a name, and we use it to store a piece of information. The crucial thing to remember is the information inside that box can change while our program is running.
Now, naming these boxes is kind of an art form. Good names are clear, they're descriptive, and they have to be a single word, no spaces allowed. I mean, you could get super specific, but then it just becomes awkward to type. The real goal is to find that sweet spot, a name that's short, descriptive, and really easy to read.
All right, our next tool is the data type. So if a variable is the box, the data type is like a label you slap on the outside of the box that says numbers only or text only. It tells the computer exactly what kind of information is allowed to go inside, which is absolutely crucial because computers handle numbers and text in completely different ways.
You're going to run into four main types pretty much everywhere. We've got integers, and those are for whole numbers, like a count of something. Then there are floats or doubles, which are for any numbers with a decimal point, like a price. Strings are any kind of text from a single letter to a whole book. And finally, booleans, which are super simple. Their only job is to be either true or false. That's it.
And here's how it all clicks together in practice. This first line is basically saying, hey computer, create a box that only holds integers, name it age, and then go ahead and put the number 45 inside. The next line creates a box for string data called name, and the last one makes a Boolean box called student and just sets it to true. See?
Okay, awesome. We have our blueprint idea and our basic materials, our variables and data types. Now we need to learn the language of the blueprint itself, the symbols of the flowchart. First up, the oval. Just think of this shape as the bookends of your program. You'll always have one at the very beginning that says start and one at the very end that says end. It's a super simple, clear way to mark the boundaries of your logic. Next, we have the rectangle. This is your action block. Anytime your program needs to do something, like, say, perform a calculation or store a piece of information, that instruction goes right inside a rectangle. It represents a process that's happening. This funky-looking shape, the parallelogram, is all about communication. It's used whenever the program needs to get information from the outside world, that's called input, or display information to the outside world, and that's output. Just think of it as the program's mouth and its ears. And now for the real star of the show, the diamond. This is where your program actually gets smart. A diamond always contains a question that has a simple yes or no answer. And based on that answer, the program's path splits, sending the flow down one of two different branches. This is huge. And finally, we have the arrows.
They are the glue that holds the entire flowchart together. They're so simple, but they're absolutely essential. They connect all the shapes and show us the exact direction of the logic, guiding us from one step to the very next.
All right, theory time is over. We have the blueprint concept, we have the tools, and we have the symbols. It's time to put it all to the test. Let's build a simple, real-world example and really see this thing in action.
So here's our simple task, broken down into logical steps. We need a program that asks a user for their age, and then it's going to tell them if they are eligible based on one single condition. Are they 18 or older?
And here's what that logic looks like written out. Don't worry, it's basically just plain English. We begin. We ask for the age, and we store it. Then we hit our big decision point. If the age is less than 18, then we display the not eligible message. Else, which just means in every other case, we display the eligible message. And then we end. It really is that simple.
And that process, thinking through a problem, breaking it down into simple steps and decisions, and then visualizing it, that right there is the absolute core of programming. It's how you can transform any intimidating, complex problem into a totally manageable step-by-step solution. So my question for you is, what blueprint will you design first?